Hello.
हेलो अमित सर, आवाज आ रही है आपको? ऐसे करेंगे। ये है अमित सर। अपने एंड से माइक खोल दिया, माइक खोल दिया या तो हेडफोन लगाओ। जी भाई, ऑप्शन होगा ना, बस क्लिक कर दो। अरे आप ही के एंड से बंद है। हाँ, फोन कर सुनाओ। टीचर आ गए, अमित कुमार पांडे हैं। ठीक है। सेशन चेयर है सबको करो।
Hello, good afternoon. Am I audible to you all?
प्रेजेंट करना है। यस, यू आर ऑडिबल। सब चलिए। हाँ, बोलो बोलो। अच्छा का रिपोर्टिंग है।
This is Dr. K.K. Bashir. Paper ID is
ये
20.
अलग है, ये अलग है। ओके ओके, वेट फॉर 5 मिनट्स प्लीज, वी आर जस्ट अरेंजिंग द। अरे मैं भूल गया आपका, आप बोलो कुछ।
Okay, sir. I'll be waiting for 5 minutes.
5 मिनट्स।
आप लोग को आवाज आ रही है मेरी? आ रही है आवाज ना? ठीक ठीक।
ठीक है। कैमरा पीछे लगा हुआ है। वहाँ बैठी आप बैठी
A very good afternoon to all of you. Today we are here to gather to hear some papers regarding the session number 12. I suppose 12 or कौन सा है? Yes. I invite. I'm very thankful for the session chairs, Dr. Amit Kumar Pandey. He is from Rajkiya Engineering College, Ambedkar Nagar, and we are lucky to have a session chair, Dr. Mohammad Faizan Farooqi sir, Associate Professor in Department of Computer Application, Integral University, Lucknow. Thank you, session chairs, for being with us, and I request you to allow us to start the session. So please allow us to start the session. Okay, sir. Thank you so much. Okay, thank you so much, sir. The first author is Dr. Kamalapuram Khaja Bushir. Are you there?
Yes, sir. I'm here, sir.
Okay. So he's our first author, and the paper title is Face Recognition of Faces with and Without Mask Using CNN. His paper ID is 223. So, Mr. Bashir, you can share your screen and start your presentation.
Thank you, sir. Thank you, sir. Thank you. Very good afternoon to everyone. I'm very thankful for the Integral University for accepting our paper. Is my screen is visible, sir?
Yes.
The slides are changing, sir.
Okay, visible.
Please press F5. Hello. Mr. Bashir, please press F5 for your presentation.
Yeah, I've been pressing, sir, but it's not been. In my screen is showing F5, sir.
Yeah,
but
it's
not
showing. You do one thing, you maximize, you zoom in your slides.
Okay, sir.
Now it's okay. It's readable. Thank you.
Yeah, thank you, sir. Thank you, sir. Thank you. I'm very thankful for the Integral University for accepting our paper. And on behalf of my co-authors, I'm presenting the paper. My paper ID is 223. The title is Face Recognition of Faces with and Without Mask Using CNN. Okay. Coming to the abstract or the overview of it, like these days, the main purpose of our paper is to classification of stress faces using the CNN, the convolution neural networks, and in analyzing the facial expressions. Okay, and we are going to find the stress assessment on the faces of the human beings accurately based on the facial areas using CNN. Okay, and the main purpose is to have the stress classification based on the models using the different architectures and processing the data. Okay, and we are going to use deep learning and machine learning algorithms for the assessment in our research work. Okay, and we have been joining the SSD algorithm along with the CNN so that we can get the accuracy more precisely. So coming to the uh, contents, the abstract outline of the paper is abstract, introduction, related works, proposed model, and next we are going to with results, discussion, and conclusion, and the references. As I discussed, the abstract that we are going to mainly concentrate on the classification of stress faces using the convolution neural networks, where we are going to check the people. Where we are going to check the people with the face, for people having with the mask as well as without the mask. Okay, and coming to the introduction, these days the face recognition technology has a greater extent over the past few years, and the research is going tremendously based on the digital images devices, and moreover we are going to go with the security and identification of the images, and we are having like face recognition is been playing a vital role in recognizing the things, and we can get the things recognized easily using the deep learning as well as machine learning. In this scenario, the computer vision is playing a vital role which will be helping us to recognize the things very easily. And not only the images, we also go with that videos that can be helping us, like moving objects also will be helping to recognize what the image is exactly. Okay, and the researchers have been already done in this particular area earlier using the support vector machines algorithm and few deep learning algorithms they have done, and we have been more specifically concentrating on the neural networks with single shot multi-box detector. Uh, Coming to the review, I mean, this is the literature related work. The earlier work already have done. They propose some support vector machine algorithm for recognition of the work, and which has been a little accurate when they were able to classify the things. They were used to detect the objects rather than identifying it more precisely. Okay, and the combination of deep learning along with the neural networks is considered as a pivotal model for recognition of the face, which will be helping us to recognize, and in more specifically we are going to find the stress of the particular person based on the gestures on the images, based on the facial uh, spatial areas where we can recognize what exactly the person is been, to what extent the person is stressed or not. So this is a comparison of the previous work where people used to check the images of the person, and they are going to check with the pixels and the pixels are being divided like different things where you are going to guess, get the sharpness is been less when we compare with the models. In this particular model, they used SVM, which was giving a little less accuracy. Then we taken the other parameter like facial dimensions, which plays another vital role for the recognition of the face. They use the CNN. It was giving much better than the earlier one. Then they use a geometric axis. This geometric axis was used along with the deep learning model, which was giving a better result, and it was having certain like loss of factor was like face embedded. Okay, and what we are proposing is like pixels along with pooling, which will be helping us to get better results when compared to the other earlier existing work. And we have been using the CNN place. We are going to use SSD in this particular process. Okay. So this is what we have. In the proposed model is like it's a computer-based method detecting, identifying, and diagnosing the stress in a person with extreme precision and accuracy by the variety of data sources like bodily clues, and speech patterns and facial expressions. Based on the facial expressions, also we've sorry trading online. Okay, and it checks the what is the percentage of the facial expressions that will be helping us to classify the stress with and without mask. And we are going to use a certain levels of the persons. I mean, the person will be having certain levels of the like exactly saying like certain levels of stress. Some will be having like little low stress, some will be having high less. So based on the different things, we are going to analyze using this particular model. And this we are going to check the different face areas, which will be giving like uh, better results of what extent the particular person is face is having stress. And we are going to propose, as I discussed earlier, we are going to propose this model along with the CNN with SSD, which will be helping us to provide the scalability, efficiency, and it's an automated stress assessment. And this is a model that softmax. The softmax is been used in the CNN model, which will be giving you the better results. Why we are going to use is that we are going to use in a CNN model, in the last layer we are going to apply this particular softmax activation, like which will be helping us to predict like taking the decision of the particular person to what extent the particular person is in having a stress feeling. In this particular scenario, we are going to just check we are going to first thing is that we are going to collect the data, and we are going to pre-process the data of the various facial images, and we are going to train, and we are going to test the faces with this particular softmax activation process. And we are going to train the procedure like we are going to concentrate on the certain parameters as we discussed earlier. We are going to take with the pixels as well as with nodes, and which will be helping it to analyze it. And we are going to analyze the accuracy with the evaluation metrics. We are going to check with the accuracy, precision, and recall and F1 score, which will be helping us to understand what the person is exactly been in the stress. These are the results. I mean, yeah, these are the results which we have been gathered. Like we have been after gathering the images, we have been trained the data sets, we validated the test, and we found that the motonically the number of training epicos are been around like 0.25. It seems like the prediction of this training example is been less. I mean, less when we are betting previously we have been discussed. Okay. And the next one is like the experimental results, what we discussed earlier. I mean, like CNN is demonstrate the robustness and performance of the various evaluation metrics, and what we proposed is better effectiveness, and it provides the test loss very rare, like it is 0.321, and the accuracy is much better, like it was 0.89 when we tested in our system. And the overall getting an average of 85%, we are going to get the accuracy in the performance test. And this is an architecture what we used in our programming, in our experimental results, where we consider the different parameters and the shapes of the images. We mean different poses of the image, and we have been using it, and we have been using with and without mask images and which will be helping us to get the pulling dense of it and flatten the things.
So, see, please conclude your presentation,
Yeah,
please.
yes.
We're running out of
So,
time.
sorry. So what I want to conclude is that when we have been gathering it, like we want to conclude that by using the CNN model, it is not efficiently, sir. But whenever you are joining the CNN along with SSD, it is going to provide the better results, and where we can use the state of art architectures and optimize the techniques, which will be helping us a benchmark for the novel inside of the field. And further, this can be applied for the uh, images where we can go with iris and where we can have the gestures and on the faces, and we can go with the uh, uh, facial areas where there will be a lot of pixels which will be having more. So this, what I conclude is that by using the CNN along with SSD, we are going to get the accuracy, and we are going to find the face recognition very easily. This is what the references which we concluded, which we use for our research works. And thank you, sir.
Thank you, Mr. Bashir. Uh, Amit, sir, Amit Kumar, sir, do you have any question to
Yes,
ask?
sir, yes.
Okay, please do ask.
First, you have taken the CNN techniques, na? Machine language. First, you have taken the CNN
Yes,
machine
sir.
language,
Yes, sir.
and you combined that with SVM.
Yes, sir.
What we have got the modification when you combined CNN.
Yes, sir. CNN, we didn't combine with the CNN, sir. We just gather the papers on the
My voice,
SVM and
you have
sorry.
used combination of the CNN and SVM in your paper.
Yes, sir. Yes, sir. CNN and SDS, SSD, sir. No, sir.
What are the advantages?
We are not used SVM, sir. We have used single shot multi-box detector, sir. That is SSD, sir.
Okay. Okay, thank you.
Thank you, sir. Thank you, sir. Thank you for giving an opportunity for us to present the papers.
Thank you, Mr. Bashir, for sharing your views. Next, I would call upon Ms. Shiva Kumari. Shiva Kumari, are you there?
Yes, sir, I'm here.
Ms. Shiva Kumari, she is our second author, and her paper title is Design of Fiber Bragg Grating versus As Vibration Sensor for Laboratory Test Train. Her paper
Yes,
ID
sir.
is 244.
Yes, sir.
Shiva, please share your screen.
Can you see my screen, sir?
Not yet.
Can you see now, sir?
Yes, it's okay now. You can start your presentation.
Yes, sir. Good afternoon, everyone. It is my great pleasure to present my paper, Design of Fiber Bragg Grating as Vibration Sensor for Laboratory Test Train. And I'm here on behalf of my co-supervisor, Dr. Preeta Sharan, Dean Research, the Oxford College of Engineering, and my supervisor, Dr. Sarah K., Professor, Department of ECE, School of Engineering, Dayanand Sagar University. And I thank Integral University for giving me this opportunity to present my paper and for accepting my paper. The outline of my paper is about the introduction, fiber Bragg grating sensor, and my problem statement, ground-induced vibration by the train, and the proposed model, results and discussions, and the conclusion. First, let me say the introduction. In the densely populated nation like India, railways are considered as the most used and cost-effective long-distance transport system. And in our India nation is considered as the fourth largest railway network because it covers more than 140,000 kilometers railroad. So we have a very strong railway infrastructure, which plays a crucial role to ensure the continuity of goods and passenger transportation. Since most of the common people and huge population depend upon this railway transport, the railway requires continuous health monitoring for safety concerns. In order to develop the safety concerns, it is good to have a smart conditioning monitoring system, which would allow us to do real-time and continuous monitoring of the structural system of the railways. The smart condition monitoring system, which I mentioned, requires extensive sensor network. So one of the option we go with is the FBG sensor, which offers many advantages over classical electrical sensors. Since my focus is towards FBG, let me give a brief description about FBG sensor. FBG is a type of distributed Bragg reflector constructed in a short segment of optical fiber that reflects a particular wavelength of light and transmit all others. So the optical fiber, a short segment is exposed to a high intensity ultraviolet rays, and the refractive index of those regions are changed. And when we pass light through the core of the fiber, all the wavelengths except the Bragg wavelength will be transmitted. The reflected wavelength is calculated by the Bragg wavelength, which is given by the formula 2n effective capital lambda. And this FBG is used for measuring strain, pressure, temperature, vibration, and many other physical parameters. The advantages of this FBG are, it is very much immune to electromagnetic interference. It's of lightweight, it's of small size, it's very flexible, and has high accuracy. Little more about the fiber Bragg rating sensor. This is the equation which I clearly explained for calculating all the physical parameters. Lambda B is equal to 2n effective capital lambda. This Bragg wavelength is determined by various factors applied to the FBG, which affect the refractive index or the grating periodic variation. The grating period or the effective refractive index varies either by temperature or strain, and hence there is a shift in the center Bragg's wavelength. So the sensitivity of the FBG is very much high. It is, if the center wavelength is 1550 nanometer, the strain can be measured as 1.2 picometer per microstrain, and also 13 picometer per centigrade for temperature. So now why I'm using this FBG? My problem statement is, since I've taken the railways as my area, the railway has many parameters, and most of the accidents are also happening in trains. So in order to avoid the train accidents, there are so many parameters to be concerned. One concern is vibration. And the vibration is generated at the wheel rail interface of the train. So when the vehicle travels on the rail, two types of forces act on the points, what they are called as quasi-static and dynamic forces. The quasi-static force is the outcome of the self-weight of the train, whereas the dynamic force is speed dependent, and it is due to the outcome of the sleeper displacement and irregularities of the wheel. Propagation of, once the vibration is generated at the wheel rail contact, the vibration slowly propagates through the soil as compression waves, shear waves, and Rayleigh waves. Then the vibration reaches the foundation, which is built nearby the railway tracks, and it affects the different parts of the building. Not only the building, the people who are housed inside the building also will be affected due to the vibration. So the vibration is not a good parameter that affects also the human beings and the buildings, whichever is constructed around in and around the railway stations. Due to growing populations, we can see high-rise building near the railway stations in urban areas. And it will create so much of problems in human beings like sleep, annoyance, concentration, motion sickness, and increased heart rate. So my focus is, like, I'm going to design a vibration sensor to measure the level of vibration produced by the train. And then I have to consider whether this vibration is a normal one or if there is any abnormalities in the train. So for that, my proposed model is design of FBG as vibration sensor. Then I will paste the FBG on the railway track, which I pasted in the laboratory lab model train. And the wavelength shift is recorded in the time domain. Whichever I got in the time domain, I converted into frequency domain by the F50 in the MATLAB. Then I could observe the difference in the vibration level. In order to observe the difference between the vibration level, in my lab model, this is the lab model of my train. Here in the track, we have a intentionally created gap in this, the first figure here. So the gap is of 5 centimeter. And here, the trail is allowed to run in the normal track. So whenever the train is crossing this 5 centimeter gap, we could see a strain, more strain developed by the train through the FPG sensor, whereas when it travels on the normal track, the vibration is less. That was a study which I did in my lab along with my guides. And this is these are the results I got it through the FBG sensor and demodulating with the integrator. So these are the strain values. These are the wave shift in wavelengths. And I measured the vibration in this way. This is converted into which I got in time domain. I've converted into frequency domain. One of the strain value I have plotted in the graph, the fourth one, the amplitude as well as the frequency level. So we can see the change in the fourth row and the fifth row. When it crosses the gap, the vibration level is high. Pardon, sir? Can you hear me?
Yes, please go on.
Yes, sir. So
Please continue.
Okay, fourth and fifth, you can see that whenever there's a when we allowed the train to pass through the gap, we got a difference of huge difference in the strain value, which we can see the dominant frequency, the maximum amplitude is plotted here in that frequency of 33.23 hertz. So what is my conclusion? What is along with our guides, we came to a conclusion that when the train is running in the normal track, the vibration is less. And when it is crossing some gaps, or if it may be a crack, or if it is some disturbance is there, then the vibration produced by the train is more. This is my finding from the experimental model. Thank you, sir.
Thank you, Shiva, for sharing your work.
Thank you, sir.
Amit sir, do you have any question to ask? Amit sir,
Yes, sir.
do you have any question to ask?
No questions.
Okay. Pradhan sir, do you have any question? Okay. So let's take up another author. We are having Majnunat S. And her paper title is Design of Name. Yes, the design of fiber Bragg grating sensor for the measurement of strain and temperature. Her paper ID is 251. Manjunath, are you there?
Yes, sir. Good afternoon, sir.
Good afternoon. Please share your screen.
Yes, sir. So, is my screen visible?
Yes, it is visible.
Okay.
Please come to the first slide.
Yes, sir. So, good afternoon, everybody. This is Manjunath S. from RNS Institute of Technology. Our project title is Design of Fiber Bragg grating sensor for the measurement of strain and temperature. This is the outline of our project. Then, introduction. Optic fiber communication is an emerging and effective technology which uses light as a medium to carry data and signals. Therefore, the optic fiber is used as a channel which in the thin flexible stand of glass acts as a waveguide for light that uses total internal reflection as a principle to propagate the signals. These optic fibers are made as fiber Bragg grating FBGs by inducing a refractive index of the fiber core that reflects a specific wavelength of light while transmitting all others. This property of fiber Bragg grating will make them suitable for sensing some of the physical parameters such as pressure, strain, temperature, etc. In this presentation, the FBG is used as a sensor for measuring physical parameters such as strain and temperature. Among optical fiber sensor, FBG technology is unique due to its simple manufacturing process and strongly reflects signals. The fiber core refractive index varies regularly along its length to form FBGs. These sensors work using the diffraction grating concept, which involves periodic changes in the core refractive index. If the Bragg condition is met, light passes through the grating structure and reflects off each grating plane, creating a signal reflected beam of light. For the following equation represent this condition, where lambda b indicates the Bragg wavelength and n effective is the effective refractive index of the core, and this capital lambda denotes the period of grating. Any changes in the period of grating or the effective refractive index of the FBG due to pressure, humidity, temperature, strain, or etc. causes a shift in the wavelength of the refracted light. Proposed model. So here we are using our helical structures to mount our FBG. The FBG sensor embedded in the helical structure connect the interrogator to an optical channel for analyzing parameter like strain and temperature. The analysis can be performed using Origin Pro software. Implementing a helical structure with the optical fiber that connects the FBG prevents distant advantage for application in sensing. These advantages include higher sensitivity towards strain and temperature uh, attributed to the grating distributed along the helical path. Moreover, the helical structure possesses the capability to the sensor resilience against bending and twisting, thereby enhancing its durability when subjected to the changing in operational environments. Results. Temperature analysis. Temperature sensing is most widely used parameter in particularly all application domains. Convolution temperatures such as thermocouplers, resistance temperature detectors are all immune to electromagnetic interference, have a large operating range. So we are using a fiber Bragg grating so that it is very compact, very trustworthy, and very immune to electromagnetic interference. The thermo-optic coefficient is the main reason why FBG temperature is sensitive. This equation indicates that if there is any change in the temperature, we can see a shift in the Bragg wavelength. The delta lambda b denotes the shift in the wavelength. This temperature analysis is conducted. As we can see in the figure and table shows that the temperature behavior in the FBG sensor, when there is a temperature altered in the helical structure, the grating period of FBG will change. This leads to the change in the wavelength. Strain analysis. The fiber's physical characteristics such as elasto-optic property and thermo-optic coefficient, as well as the kind of strain, we can see the change in the wavelength as this epsilon indicates a change in the strain. If there is any change or alterations in the strain, we can see a direct change in the Bragg wavelength. This is the strain analysis. For 200 grams, we have conducted the strain analysis in grams, and we obtained a strain equivalence and center wavelength change in the FBG. The figure and table illustrate that how the FBG sensor behaves under strain. The strain equation indicates that epsilon delta L by L is nothing but the change in the length applied to the tip of the helical structure is due to the initial change alter in its length. So we can see a shift in the wavelength. So this we also simulated using RSoftCAD in the grating mode. As we can see that when there is a strain or temperature applied on the FBG sensor, we can see a shift in the wavelength. So this is the simulation result. We have used MATLAB to plot the strain versus pitch period change, and we also use the temperature versus pitch. As we can see, as the temperature increases, we can see a shift in the wavelength. Same also, as we can see a shift in the strain, we can see a shift in the wavelength. So our conclusion is a high sensitivity FBG with sensitivity enhancement achieved through helical structure. So we have utilized helical structure to enhance the sensing capability of FBG. The helical structure demonstrates the ability to strengthen the sensor resistance to bending and twisting, consequently improving its longevity. Using ORSOFT, various FBG parameters such as grating length and pitch period are stimulated. The proposed model exhibit excellent sensitivity which are comparable to the standard sensitivity values we obtained 10 picometer per degree centigrade for temperature and 2.2 picometer per change in the epsilon for strain, ultimately decreasing the sensor response time. Moreover, this design model has capability to precisely measure both strain and temperature. Thank you, sir.
Mr. Manjunath, hello.
Yes, sir.
Can you come to the slide where your graphs are?
Yes, sir.
The slide before this? Yes, the
Yes,
previous slide? Yes,
Yes,
this
sir.
one. Yes. So what is on the x-axis? What have you plotted
Sir,
on the x-axis?
Sir, it's time, sir. And
on
in
y-axis?
y-axis is temperature. Temperature, sir. So we have given a temperature of 20
220
degree.
Yes,
Yes, sir.
140-degree temperature you are talking about, and you are talking about time in seconds.
Yes, sir.
So from where does this time came from?
Sir, actually, while taking data from the interrogator, we will get the data in time format,
No,
sir.
in the slide you have mentioned pitch period,
Yes, sir.
wavelength change,
Pitch
center
period.
wavelength change.
Yes, sir. This
Yes,
pitch
in this
period
table the time
indicates.
is, yes, in this table time is not mentioned. Where
Yes, sir.
does this time component came from?
So actually, while taking data from the interrogator, we will get data in time only, sir.
But
So
it is not
as
shown. It is not shown in the table.
yes, sir, it's not shown, sir.
Your graph and your table is not matched.
Yes, sir.
Both
Right.
are telling the different story.
Yes.
There should be some coherence between the table and the graph that has been. Now, can you come on to the next slide, please?
Yes, sir.
Yes, this. What is on x-axis?
Sir, it's time.
And what is on y-axis?
Strain, sir. Applied strain.
Yeah, it can be negative. It can be positive.
Yes, sir. It
What is
depends on
negative
the
strain?
how we will mount the FBG onto the helical structure, sir.
But in the table there are only positive. Are there any strains, negative strains in the table and time in the table shown?
No, sir. It basically denotes. It basically denotes that the mount, the
No,
sensor mounted is.
Where in
Yes, sir.
table have you shown these negative strains and time? There should be
No, sir.
correlation between the graph and the tables.
Yes, sir. So basically, we have mounted the FBG sensor against to the gravity, sir. So it's showing negative parameter. So we have converted it to a positive, and we will plotted this
But your
strain
result
and
should
pitch
speak
period,
for
sir.
themselves. So your result should speak for themselves.
Yes, sir.
There should be some coherence between the graph plotted and the table shown.
Yes, sir.
Yes. So where is the time in your table? Or you can take any time you want, you please.
Sir?
You should write the time in whatever you want
Yes,
to
sir.
say, whatever you want to show, just to show in a table form, right?
Yes, sir.
And that too,
Yes, sir.
it seems that you are taking the value of positive weights.
Yes, sir.
And the value of strain, these are different. The value of strains are different. See in the table, or the
Yes,
table
sir.
has nothing
This
to
is
do
the
with the
weight.
graph.
Yes, sir.
Manjunath, I have one more question. With your permission,
sir.
Amit sir, Amit Kumar sir, with your permission, can I ask a question?
In your slide, you have not shown any references.
Sir?
In your slide, I think
Yes, sir.
there's reference.
No references.
Sorry, sir.
He's asking for the references. In your slide, no references are there.
Yes, sir. I didn't add any references in the slides.
You should add the references from where you have taken the slides.
Yes, sir.
Manjunath, one more question last. You
Yes, sir.
talked about the optical connectors, right?
Yes, sir.
And what is the
Yes, sir.
difference between optical connector and an optical fiber core?
Yes, sir. Sir, optical connector basically which connects two fibers, sir, where optical core is nothing but a core which is mounted by a clad and extra material to protect the core.
Okay, which material does the optical fiber is made?
Sir, basically silicon glass material, sir.
Silicon, optical fiber.
Yes, sir. Sir, glass.
What is the principle on which the optical fiber work?
Sir, principle on total internal reflection, sir.
Yes. Thank you. Thank you, Mr. Manjunath.
Thank you, sir.
Thank you. Please leave. And thank you for your such presentation. Next, Miss Hira Javed. Are you there? Miss
Yes,
Hira?
sir. Yes,
Okay,
sir.
okay. Her paper title is Summarizing Across Modes, Integration of Asynchronous Images and Text. Her paper ID is 297. Hira, please share your screen.
Yes, I'm sharing. Visible, sir?
Yes, it's visible. Please start your presentation.
Okay, good afternoon, everyone. The topic is summarizing across modes, integration of asynchronous images and text. My paper ID is 297 and I'm from Department of Computer Engineering, Zakir Hussain College of Engineering and Technology, AMU. So this is the outline of my work, which is the introduction, related work, proposed model implementation and all. So basically the introduction is that we have vast amount of data that is there in textual and visual modes that is available. And when we summarize, we generally use the data in the textual form. But with the increase of the multimodal content, it is definitely the amount of information that is there that should also be used for generating the summaries that are there. So this study presents a system for multimodal summarization that can automatically produce summaries from the news documents by using different modes. So we have used the textual mode also, and we have also used the visual mode here for the generation of summaries. So the relevant text is extracted from the news articles using this information, and our approach uses the transformer architecture and attention in images for the generation of the summaries. So the main contribution is to bridge the semantic gap between text and images. So text is one mode and image is the other mode, and we need to just have some semantic understanding of the image in order to generate the summary from the image also, in order to capture the information from the image, and that will result eventually in the formation of the summary. So for that we have applied the transformer architecture and the attention mechanism on the images, so that we may understand the important aspects of the images, and consequently those aspects of the images are considered while generating the textual summary in the output. So the performance of the summary has been later evaluated using the root score. So this is a related work. Earlier also work has been done. For example, in summarization of sports, some play breaks have been identified in the games like tennis, soccer, and football, etc. Highlights from golf match. So earlier works that have been done, they have been done using the synchronous data. Synchronous means that the images may be having the subtitles, or the videos will be having the subtitles, and so images will be having the caption and all. So the work that we have done is basically on asynchronous data. That means the image do not have the caption, and also the video that have been used do not contain the subtitles. So that is the asynchronous data. So to identify the semantic information from such kind of images or the videos is a difficult task. So we have used the encoder decoder framework for that, and this is our So this is the proposed model. So what we have done is for the encoder decoder framework, we have used some images and we have also used the captions of those images. So what our objective is that we have to identify the probability of the caption given the image. So when we have for example, an image is there and you have the caption, then what we do is, first of all, we identify the image features using VGG16, and we also identify the word features using the word embeddings there. So once we have the image features or the feature map for the image and the word, for example, the embedding for the text that is given to the LSTM encoder decoder network, which in our case is the LSTM here that we have used for the decoding purpose. So dense image features and word embeddings have been used and are fed into LSTM and RNN that will produce new words here. So the basic idea is to optimize the equation that is given here, that is log probability of C comma I, where C is the caption and I is the image. And over the entire training data, we have actually optimized this equation that is given by summation T equals to 0 to n log probability of caption at given time T, given the image, and given the previous words of the caption that are denoted by C0 to CT minus 1. So this is basically the encoder decoder approach that is used here. So so one more that we are giving is, we are giving the feature map of the image, and we are also giving the word embedding, and the final output that is being created is the caption. That is means the caption of the image or the description of the image has been identified. So this is the first part of our work. So what we have done is, we have first of all identified. Yes, sir. So we have
Yes,
actually.
what is log probability?
So log probability, for example, we have this conditional probability that is given here. So we have just applied the log for that on that.
What is maximum value?
So for the probability, we have actually for the probability, the maximum value is from is 1.
And what for log probability? What's maximum
So
value?
so we have actually
Both are same.
so we have what we
Both
have
are
applied.
same, or both are same, or they are different.
So we have applied logarithm on probability, so that just as to normalize it, because when we will do this, so what will happen, the
So
probability
what will
may
be the
come.
result? What is log 1?
So log 1 is so log that means log if it is base 10, then log 10 is 1,
Log 1. What is
and
log 1? This is base 10
log 1 will be
or
0.
E? This is base E.
Then,
This is
yes, sir, so
base
this
E.
is given by log 10, base 10.
What is RNN?
So RNN is a recurrent neural network that is used to generate that is used in encoder decoder framework,
Okay, next slide.
and that.
Please, next slide. Move on to the
Okay,
next slide, please.
okay, so okay, so so what we have used is here that the equation is given. So we have two parts for this work. First one is the image feature extraction, and second is the vocabulary building. So in the image feature extraction, we have extracted the features using the VGG16, and for the vocabulary building, what we have done is, we have actually taking the caption of the image, and we have assigned numerical values to it using the embedding.
What is
Uh,
VGG? What is this VGG16?
so VGG16 is a CNN.
It's a CNN.
Yes, it is a deep convolution neural network, and it is a
What
pre-trained
its
model.
what
It is
is
a
its full
pre-trained
form?
model.
What is its full form of VGG?
So the full form of VGG is a visual geometric group. Visual geometric group, yes. So there are two versions, VGG16 and VGG19. So this VGG16 we have used. This is basically a pre-trained architecture. And it is actually a deep convolution neural network. So it is a pre-trained architecture wherein, if we will remove the softmax layer, then we will be left with the 4096 dimension. So we can use that dimension for identifying the feature of the image. So am I audible?
Yes.
Yes, sir. So this is basically a pre-trained neural network, that is pre-trained CNN. And what we do is, it has been actually trained on ImageNet database. So what we usually do is, whenever we are giving an image to this network, so what happens in the last layer, we remove the softmax layer for the prediction, and in the last layer we will be left with 4096 dimension of the image. So that will be a kind of image vector that we will be getting. So in order to give that image vector to the LSTM for this purpose, for the identification, for the generation of caption, what we have done is, we have given that image to VGG16. It is just for identifying the image feature map for that.
And 16 is for layers.
VGG16, there are like two versions for this, and this is it is like weight layers that are given, yes. And there are VGG19 is also a version which consists of 19 weight layers there. So there are some convolution neural network layers also connected. So all the total number of layers is 16 there. This is the weight layer that is there.
Please make it fast, Hira.
Okay, fine. So vocabulary building is the second step. So now for the implementation, so we have actually used, in the first experiment, we have used LSTM, attention mechanism, and VGG16. So for the images, what we have done is, we have identified we have used attention mechanism so that it can identify the important regions of the images there. So when we pass the important regions of the images there, and also the word embedding there, then the final output that is being obtained is the caption that is generated. So once we have the caption, that means for the particular image, we have a caption or a description that is there for that particular image. In the second experiment, what we have used transformers for that. So transformers are basically they contain of multiple parallel heads. So the words or the image patches will be processed at the same time, at a single time. So here the encoder is taken. So in encoder decoder framework here, what has been done is that image is taken and the positional encodings have been identified, and then target captions have been produced. So there are two methods that we have used. So first one is attention mechanism, and second is the transformer. Now the third step is that once we have identified the captions for the image, what we have done is we have actually what we have done is we have used the So what we have done is we have identified the semantic similarity between the sentences of the document and the sentences of the images. So for that we have used sentence. So we have used sentence word to identify the most similar sentences from the text to the given image. So basically we have an image and then we have a caption to that. Now whatever caption is there, we have a textual summary that is there, or textual document is there. So what we do is we match these image descriptions with the text there, and those sentences which are quite similar to this this caption of the image, that are taken to be identified in the final summary. So what we have done is for each document we have identified two sentences there, two more similar sentences to be incorporated in the final summary. And in the data set that we have used, we are also having the reference summary there. So we have used the Rhodes score for the evaluation purposes there. So these are the final results. So we were in the data set, we were having different topics of the news. So there are 5 topics that we have taken, and for each topic we have identified the Rhodes score given the first framework, which is for attention, and the second framework, which is for transfer. So finally, this is the result and discussion here. So the challenge in the visual mode is that, for example, whenever you have textual documents, we can just pick out the sentences, and those sentences are quite structured. While when we use images, the problem is that, for example, if a person is waving hand or Donald Trump is waving hand, so we cannot just identify the person as Donald Trump easily. So we can just say that the model will produce the result like a person is waving hand, and it will not necessarily tell you that
Yes,
it is until
Hira.
yes.
Hello, Hira.
Yes.
Can you get back to that table?
This one?
Yes, this table.
Yes.
Topic number. What are these topic number?
So actually the data set that we have used
some textual information should be 1, 2, 3, 4, 5. This is the topic number. What should we understand from this?
Okay, so actually the data
Some
set that I
textual
have, that
information
was
should be there, or
numbered.
some figure should be there, so that
Okay.
we could relate. And what are these numbers?
Sure, sir. So this is actually the road score that is used for the
Okay, what
evaluation
is
of
this
some.
average? Okay, fine. What is
This is
this average?
this is the average of Roach one, like across all the 5 topics.
No, you
The
have
first,
mentioned weighted average. You have mentioned in your text that weighted average will be calculated, and you are writing
no,
here average only. Yes.
so
On the
weighted
next, please.
average. Yeah,
Yes,
yeah. Oh,
please.
weighted
Can you
average
go?
is for,
Yes.
yes, sir. Weighted average for LSTM purpose. That
Yes.
LSTM that we use that here, I think here I have
Yes, you have
written.
mentioned this, na, ki you will use this as a weighted average.
Yes, sir. The input takes into
So
the subregion while the output is a weighted arithmetic. So this is for the description of
output,
image that
yes,
we are getting. So
weighted
the description.
arithmetic mean.
Yes, sir. Yes. So
Now, my
what
question is,
we have,
yes, your output is weighted arithmetic mean. What is the difference between this weighted arithmetic mean and the average that you are writing over there?
so that weighted
Both are
arithmetic mean
different.
that is, sir,
Both are different.
yes,
Mean is
sir.
different
Yes,
from
sir.
average.
So mean and average are same.
Yes.
So
And what is weighted
actually,
average?
so it is the measure of central tendency when we have some observations. But here, what I have done is that this is for the description of images. That means first of all, I was having an image, and then I took out the caption from that, and then I
Now, my
matched
question
that
is very
caption.
simple. Please get back to that table.
Yes, sir.
Yes. Now, what
So
is this?
this
This
is for
average.
sir, this is
Now,
actually, so let me,
my question mark is on this table only. Topic number,
yes, sir.
first of all, topic number is not visible or not
Okay, sir.
there. It is absent over there. There should be some topic. Please get back to that table. Now, this is, you have mentioned about the average output will be average, weighted average.
Sir,
Is that,
actually,
is that
make it clear.
this average, is that mean only?
So no. So this is for the summaries that I have generated. So this is for the summary. This average is for is the average of the road score, and that was a different thing. That was for the description of the image that I was taking.
Okay.
Yeah,
And
yeah.
where are
So
the graphs that you might like to plot in your PPT? There is no graph that so that we can get better understanding of your result.
okay, so that I will use actually so there was some limitation on the number of slides, so I didn't add. Okay, I'll add
Okay,
for
previous
fiber
slide,
because
please. Previous slide, please. No,
previous this one, right?
yes. What is loss function and how it is different from activation function?
So loss function is used to measure that actually the difference between the predicted and the actual value that is there. And activation function is basically used for the in case of neural network. So it is the ReLU or that the function that has been used
And that too, batch
to learn
size is also
patterns
very
of the
small
data.
in your case. Batch size is small, isn't it?
So there was this limitation, this 32 or 64 that can be because there are a number of the size of the data set is 8,000. So we use the batch size of 64 here
Why the
in.
number of epochs are only 50?
Sir, actually it takes a
You are
lot of time
satisfied,
for
you
no,
were
I had
satisfied with the
to
50 epochs only.
no, I had to actually compare the results. So what I did was, first of all, I tried with, like, it takes a lot of time because there's processing of image also and text also. So in case of for the comparison purpose, what I did was I limited it to like 50. We can also like, I can increase it also. But for the comparison purpose, as for now, I because it took like for like several hours, so there was some
What is this
resource required.
optimizer? What is this optimizer?
So this has been this optimizer is used for optimizing the neural network that we used, right?
Most of the parameters are same in both the cases.
Yes, so for the case of comparison, I have actually used that dropout rate is different, and number of attention heads have been increased in case of transformer.
Except number of attention heads.
For maintaining the uniformity, because
This
we
could
had
have
to compare
this could
this.
have been same also. Then the result would have been
So which
okay. Think on it. Think on it. Thank you,
okay.
Hira.
Thank you,
Okay.
Hira. for your views regarding the images and text.
Okay, thank you, sir.
Thank you. Next, we have our last author, Ms. Farazia, Assistant Professor in Department of Computer Application.
Take that
The
mouse. Take that
Wait,
mouse.
Her paper title is Precision in Tracking, a Role of RFID in Asset Visibility. Her paper ID is 155. मैम एक मिनट हो गया रुकिए एक मिनट मैम प्लीज मैं एक मिनट Please start your presentation.
The content is Introduction, RFID Technology Overview, Types of RFID Tags, RFID Reader Characteristics, RFID Middleware, How it works, RFID Workflow, Issues and Challenges, Practical Application of RFID, Conclusion and the Future Work. So here I'm going to give the introduction. What is RFID? RFID is radio frequency identification, asset tracking. Basically, it enhances asset visibility and operational efficiency.
Very old topic. Any honest review? Do you want honest review?
Sir, really, please give the honest.
It's a very old topic.
Okay.
And your work is missing. Any graph? Any tables? Have you got any tables and graph with you?
Yes.
Come to the result.
Result part directly. We know this. See, it's only a review.
Yes, sir.
It's only a review.
A reviewed paper.
It's a review.
Yes,
Your
sir.
paper mentioned that. It's
Yes,
a
sir.
review. No.
Role
Role of RFID. How can you make this better?
Sir, with the help of.
What is the range of radio frequencies
Sorry, sir.
on electromagnetic spectrum?
Sorry, sir.
That you should have displayed electromagnetic spectrum, and there the lie, there that lie. It's from violet to red.
Yes,
That's
sir.
a visible part, and before that there are radio waves. Oh, that thing. What is IoT?
Sir, Internet of Things.
Yeah. What is the full form of RFID?
Sir, radio frequency identification.
Okay. Very good. Very good. But more is expected from you.
Okay, sir. Inshallah, next time I'll come
It
with
seems to
the
be a
better
very
answer.
mediocre type of my honest reviews. I
Okay.
expected more.
Okay, okay, sir.
Thank you for your presentation.
Thank you so much, sir. मैंने इतना जल्दी एक्सपेक्ट नहीं किया था कि आप लोग मुझे छोड़ देंगे
तो ज्यादा जब वो फॉर्मूला रिपीट हो जाता है एक बार मैं सो ही रहा था
Amit sir, we are done with the presentation part. Amit sir. So this brings the end of the session, and I really thank Dr. Amit Kumar Pandey sir and Dr. Mohammad Faizan Farooqi sir for being with us and asking very good questions. And really, we understood the importance of this session and the papers which were put up in this session. Thank you so much, sir, for your present special time. Thank you so
Thank
much.
you.